Hello everyone, welcome to the channel. Today we are diving deep into the world of mid-latitude cyclones, a powerful weather system that shapes the climate in many parts of the world. In this video, we will break down what mid-latitude cyclones are, the general characteristics of mid-latitude cyclones, the areas where mid-latitude cyclones form, the conditions necessary for the formation of mid-latitude cyclones, the stages of development and related weather conditions, reading and interpreting satellite images and synoptic weather maps. So make sure to watch till the end and don't forget to like, comment and subscribe for more geography content. Let's start. So what is a mid-latitude cyclone? A mid-latitude cyclone is a low-pressure system that brings together cold and warm air masses, causing clouds, strong winds, and precipitation. Let's look at the general characteristics. The isobars are closed around a low-pressure center. When isobars are closed around a low-pressure center, it means that the area is experiencing a cyclonic system. This is an indicator of unstable weather. The wind blows from high pressure towards the low pressure from all directions. As the wind moves toward the center of a low pressure, it is deflected by Coriolis force. The deflection is to the left in the southern hemisphere and to the right in the northern hemisphere. As a result, the cyclonic airflow is clockwise in the southern hemisphere and it is anti-clockwise in the northern hemisphere. Air converges and rises at the surface of the earth and diverges in the upper air. Mid-latitude cyclones also have other characteristics that distinguish them from other cyclones. They are systems where cold polar and warm subtropical air masses meet. The boundary between the two air masses is called the front. The pressure at the center is about 996 hectopascals. They usually occur in families. This means that a few of them form one after the other. They travel at about 50 to 60 kilometers an hour, covering 1,200 kilometers in a day, and they last between 4 to 14 days. Areas where mid-latitude cyclones form. Mid-latitude cyclones form between 30 to 60 north and south, where warm moist air from the tropics meet cold drier air from the polar regions. The two masses meet along the polar front. The westerly winds blow in the same latitudes too. In winter, mid-latitude cyclones move north following the migration of the sun. Conditions necessary for the formation of mid-latitude cyclones. Mid-latitude cyclones need the following conditions to form: a mass of warm air meeting a mass of cold drier air. The upper air divergence to remove air that is ascending, and this is required to make continued ascent possible. Something to trigger the development of a low pressure center. Mid-latitude cyclones go through 4 stages from their initial formation to their degeneration. The first 2 stages make up the process of cyclogenesis, which is the development and strengthening of a cyclone. Stage 3 and 4, the cyclone weakens and it disappears. In the initial stage, or first stage of mid-latitude cyclone, warm tropical air masses meet cold polar air along the polar front. There will be a big difference in temperatures between the two air masses. The wind on either side of the polar front blows in opposite direction. The front does not move. In the developing stage, a kink or a wave develops. This development is caused by jet streams, or it can be a cause of mountain ranges, which they disturb the motion of air flowing over them. The rising air causes the pressure to decrease, thereby creating a center of a low pressure. This causes cloudy weather and some rain, which will occur because of the rising warm air. The mature stage occurs in about 24 hours after the initial formation of the cyclone. The wave increases as warm air moves further into the mass of cold air. Warm and cold sectors are fully established. The two fronts develop, marking the boundaries between cold air and warm air masses. Each front is named after the air that is behind it. The warm front is in the east, and it is ahead of the warm air. The cold front is in the west, ahead of the cold air. The whole system moves from west to east. The symbol used along the lines of a front indicates the temperature of the air behind the front. Let's look at the vertical section of the cyclone when it is in the mature stage. The vertical section shows the cyclone from the ground level up into the air above. Air rises along the warm front. The warm air from the warm sector rises above the cold air ahead of the warm front. The rising air along the front leads to condensation, cloud formation, and the rain. The rising air causes the pressure in the center of the mid-latitude cyclone to drop further. We will look at the vertical section in more details later. Let's move on to stage 4. Stage 4 is known as the occluded stage. In this stage, the cold air behind the cold front travels faster than the air in the warm sector. As a result, the cold front catches up with the warm front along most of its length. The warm air is forced to rise, leaving only a very small warm sector on the ground. The cold and warm front will join, and this becomes the symbol of an occluded front. It is a combination of the symbols for a cold and a warm front. Heavy and widespread rain will fall along the occluded front. The last stage of the cyclone, this is after the occlusion, when the cold front get caught up with the warm front, pushing the warm air upwards. So in this stage, the entire warm sector is above the ground, and there is no warm air on the ground. Isobars resume to regular patterns. This will be because of the mid-latitude is no longer present. There will be light gusts of air on the ground. Let's look again at the cross-section through a mature mid-latitude cyclone. The warm front has a gentle angle. As a result, it covers a wide area. Warm moist air from the warm sector rises over the warm front, causing the clouds to form. 3 cloud types are associated with the warm front: the high-level cirrus, the autostratus, and the nimbostratus. They form because the air did not rise much higher to form heavy clouds, since the slope is gentle. Soft rain will fall because of the gentle uplift. The cold front is much steeper than the warm front, so the uplifting is very high. Cumulonimbus clouds form. The clouds are associated with the heavy rain and thunderstorms. The area which the rain falls is usually smaller than the rainfall area associated with the warm front. As the cold front arrives, temperature decreases, pressure increases, humidity decreases. Since cold air do not hold lot of water vapor than warm air, the wind backs from being ahead of the front to be behind it. Let's look at the weather associated with the occluded front. A cold front occlusion is formed when the cold air behind the cold front is colder than the cold air ahead of the front. When the occlusion begins, the warm air in the warm sector is forced to rise above the ground. The cold front touches the ground while the warm front is lifted off the surface. Cold wet conditions are experienced on the ground. A warm front occlusion is formed when the cold air ahead of the warm front is colder than the cold air behind it. So in the process of occlusion, the warm front touches the ground. The less cold air behind the cold front is lighter than the colder air ahead of the warm front. And so it rises above the colder air. Let's move on to reading and interpreting satellite images. Mid-latitude cyclones are visible on the satellite image because of their unique band of clouds associated with cold fronts. They form a family of mid-latitude cyclones. The older cyclone is located east of the younger cyclone. On a synoptic map, cold front are clearly marked by solid lines with the triangles pointing in the direction in which the front is moving. The colder air is always located behind the line. Temperatures are always high ahead of the front, as the cold air behind the front has not yet arrived. The wind backs as the front passes. Backing means change in wind direction in an anti-clockwise direction. This helps to predict wind changes in wind direction as the front passes. There is likely to be more cloud cover and rain behind the front, though these conditions are also sometimes not found. Cold fronts are sometimes associated with thunderstorms and snow. Always check the precipitation symbol